It's the second day of the first month after getting the layoff. So let's solve some Leetcode question. So to solve the yesterday Leetcode question, because I was trying to understand the question by myself before sharing with you guys. So the question is a maximum number of the text you can assign. So we have a number of text and m worker. Each text have a strength required stored in the zero index integer array, with I text requiring the text of I strength to complete. So that means we will have a list of the text and a list of the worker. So the continue reading is each worker can be only assigned a single text and they must have a strength greater than or equal to the text requirement for the strengths. Additionally, we also have a pill, which is a magical pill that will increase the worker strength by strength. So we can decide which worker can receive the magical pill, but there's a one constraint: we can only give each worker at most one magical pill. So we have zero index integer array with text and worker, and then the integer pills and strengths return the maximum number of tests that can be complete. So my ideal solution is if we solve the problem like that, that can be solved by using the kind of a combination of the binary search. So let's run through it for the first example. So for the text, we got like 3 tests which need the strengths of 3, 2, and 1. For the worker, we got the 3 worker. So 1 worker have a 0 strengths and 2 worker have a 3 strengths, and then we have 1 magical pill, and then the magical pill will plus the strength of 1 if we give that magical pill to the worker. So in this example, we can assign the magical pill and text as follow. So give the magical pill to worker 0, since the worker 0 have 0 strengths. So if we give the magical pill to the worker, so the worker begin receiving the strength of 1. So let's do some visualization here. After the 0 index worker receive the magical pill, it will be 1, 3, and 3. For the text, it will be 3, 3, 2, and 1. So what do we do? So we have a worker 1 with the strength of 1, which can solve this text. That means we can solve this. The result will be 1 now. So for the text, there's a 2 text left and 2 worker. Since each worker in the worker list is more or equal to the text, so we can solve for that means the result is 3. Okay, that's pretty straightforward. So let's move on to the example 2. For the example 2, so we got a 2 text and then 3 worker. So here's something to think, because we have 3 worker and then text as 2 text. So we can only solve the 2 tests, and then we have only 1 magical pill which plus the strength of the 5. Even though we give the magical pills to any of the worker, the strength will be only 5 and only 1 worker will be able to solve the test, so the output is 1. So that also makes sense. For the example 3, so we got the 5 workers and then test is a 3. And then we have 3 pills. Each pills will give the strength of 10. So give the magical pill to the worker 0 and then the worker 1. Since these are the worker, so we will be visualization the example 3. So we have worker 5, 0, 10, 10, 10, and 10. For the text, we only have 3 texts, 10, 50, and 30. So result I will initially put as a 0, and then we have pills is equal to 3 pills. If we give the 1 pill to the index 0 worker, so the worker will receive the plus 10 strengths. Then we have 2 pill left. After that, so the worker can do the text 0. So let's see. Okay, after that we give the another pills to the worker of the index 1, which began the strength of 20. So it can do the text of index 1. So we only left for one test. So at the time result will be the 2. So even though we give the pills to the leftover pills to the any of the worker, which is like 3 worker, each worker have a 10 strength, that pretty sure we're not able to solve the remaining text. So the result will be 2 in that case. Alright, let's jump to the solution. So to jump to the solution, we may need to create the total text. Let's create total text, since we want to save the performance for calculating the array of the text throughout the solution. Another is the total workers. And next is workers. Since we need to sort the worker and text in ascending order, which will make as a, oh silly me, this one should be workers. Let's sort it out. By the way, I'm solving all the legal problem in the Swift, since there's nothing much going on about like solving the legal problem in Swift in YouTube. So yeah, I'm trying to create more content regarding to the Swift. Sort that, and then let text sort that. That is the busiest for us. And then we're gonna use binary search. So to use the binary search, we may need the left and the right pointer. Let's call it left, starting from the index 1, for right, which is the end, because we need to think for the edge case, like only 2 tests and a 3 worker. How about we only take the minimum numbers between them? Another is we need a result to shoot it out. Then let's do some binary search in here. Right, left is equal to right. We need to calculate the mid. So its mid is left plus right by 2. So we need the check condition in here, which is going to check whether we can solve the text by the worker strengths or not. And then we will put the result in here, and then we will reduce the mid by 1. If yes, we will increase the mid by 1 for the left. That will return the result in here. So next step is to implement the check function here. How about we copy the same parameters as here, and then we create like this, and then we need to put the one more parameter called the mid, which is going to divide the input array by half. Then we return the boolean to see whether it can solve or not. Same one, we also need to calculate back the worker count. Let's go to the worker. Also, we may need to update the pills. So let's copy the pills in here. Then we will use a pointer. So in here, I'm using the pointer and detecting the total worker -1. The reason is I want to put the pointer on the right side of the array, which is the end of the array. But if we directly use the total worker, which will be out of index, since this is a total worker count, let's see, worker count is a 3, and then we have to less index will be the 2. So that's why I'm detecting the 1 in that case. So next is available workers, so which I'm going to use a DAG in here. So DAG means, some people call it DQ or DAG, whatever, but in Apple documentation is called deck. Here. So it's mentioned the pronounced deck. Alright, let's get back to the real problem. So this will be the available worker. I'm going to prepend from strongest to the weakest. That's the reason we can get the strongest worker by removing the first of the deck. Let's iterate it the pointer by the half by reverse way. Let's call it text index because we're going to iterate through the text. To reverse in the Swift, we have to use the strike around mid detect -1 because the mid we passing through is calculator 1, and then we also need to go through 0 by -1. Next, we need to check the pointer is greater than or equal to the total workers minus mid. So the reason why I need to check is the pointer is stay greater than the total worker half by detecting the half of the mid. And I also need to check workers pointer plus strength is greater than equal to the text of the last that which is in the text index in here. Oh, there's a typo in here. So the reason why I'm placing the strength in here is even though the worker or the pointers in here may or may not be able to solve the problem, I want to fully utilize the pills because don't want to left the pointers or don't want to left the worker without using the pill or not able to solve the text. So next step is I will prepend the workers by pointers, and then I will move the pointer to the left side. Next is check the should be the prepend in here. If empty, if the available worker is empty, mean like there's no worker can take the text, then we can totally return the false. If available worker is not empty, that means one of the worker can solve. So what we can do is we can double check. So last index of the available worker, I mean this is the weakest worker, is greater than or equal to the text of individual text. We're gonna remove the last one because even though the weakest worker can solve the strength, so we can directly remove less of the available worker. So else we need to check if they have pills to use for the strengths. If yes, no more pill left, then we just directly return false. If pills still left, we can use the pills and detect -1, and we also can detect the strongest workers from our deck. If everything's went well, we can just directly return the true. So we need to call in here. So to call in there, we have to pass the same parameter like the mass text assign method. Text and mid. Alright, I think that is pretty much of here. So I need to update the result by mid. Let's try to run it through. And there's an error in line number 34. Oh, there's a typo. Sorry guys. Alright, let's solve all the case. Let's try to submit. Nice. So I think that time complexity will be O of n log n plus m log n, and in that case will be the text and m will be the walker. Let's see. Yeah. Then for the memory will be O of n plus m, so which is a walker plus text. Right. See you tomorrow. Bye.